The uncured rubber sample is now going to be squashed between these two plates, and these two plates are heated, and the rubber sample gets squashed and heated between two hot plates, and it starts to cure. During this process, the bottom and top plates subject the rubber sample to a torque force, and that torque force feeds back to a PC, and it produces a graph. And from this graph, this curing over time graph with the torque force will mean that it can give the operator certainty that the rubber meets the spec required to make whatever end product they're making using the rubber. And here you can see the actual graph being written in real time as the rubber cures, because it's between two hot plates. So this graph would be compared to a previous graph using the same material to make sure that the feedstock is of the right spec. Now the rubber sample can be removed. It would be still hot to the touch, but that would give the indication to the operator that it's all okay for the rest of the batch to be used. You can see the imprint of the torque plate. You can see it's got grips that the rubber is melting into. This is to ensure that the rubber is actually subjected to the torque force and that there's no slipping or sliding between the hot plate and the rubber sample. So notice that the TRX is not required during this operational phase. The TRX and the CBES load cell is only required during calibration. Typically, Prescott Instruments would go out to their customer sites. Customer sites would have machines like this one, and they would calibrate the internal load cell every 6 months to make sure that the compression force was as it should be, as it was being read by the internal load cell. You can see here that Tom is setting it up to demonstrate how it can be automated to auto load. So this is where it can do many samples at a time. This is to obviously speed things up for materials testing in factories that may be using numerous feedstocks into the same product, or indeed using lots of different shipments because they're making a lot of product. Either way, this will confirm that each sample is going to meet the material specification. Now, for the purposes of this demonstration, Tom hasn't loaded up all the sample spaces, he's only done one. So we'll see the machine going through, making sure there's not more samples as it's programmed, and normally this tray would be full of rubber samples, but for today's demonstration we've just got the one. You can see it checking now for other samples in the sample cassette. So here we see the sample being squashed again and heated, and those two plates are rotating against each other to generate a torque across the curing rubber sample. you can see, if you look very carefully, the new graph being created is very close to the previous graph or the template graph. So you can see that the material matches, its characteristics match very well to the default graph.